Hi, everybody. So today we're going to be talking more about graphs of polynomials. I know I introduced this really briefly in 6.5, and it was probably like, I have no idea what's going on. So we're going to kind of summarize some of the information today, more of the important pieces of today's lesson before we, I guess, finish chapter 6. So first and foremost, if you notice with every odd degree function, the arrows are pointing opposite directions on each side of the graph, right? So if you have something that's odd degree, the ends go opposite directions. And when your ends go opposite directions, I used to teach it this way, odds. I look odd while I'm doing this across the room. So I call it the snake function. Usually when you have an odd degree function, it looks like a snake. And usually it goes up as we go to the right if your leading coefficient is positive. But if your leading coefficient is negative, it flips, right? So then your snake is going to be going down to the basement, right? Sorry, I'll get my face out of the way, right? That's different than an even degree function. All of these are going to either look like U's or W's, which means your ends are going to go the same direction. And if your ends go the same direction, if your leading coefficient is positive, it should open up and be like a smiley face, right? It could also have like a W shape. And then if your leading coefficient is negative, then that frown, well, that smile turns upside down into a frown, right? So that's kind of a general summary of something that we learned in Algebra 1 that you probably didn't remember. But we're going to take an Algebra 2 spin on it and talk about end behavior. We did mention this in Algebra 1, but we're going to do a little bit more of a formal way of talking about this. So end behavior is a description of the values as x approaches infinity. So this is how we would write as x approaches infinity with symbols, or as x approaches negative infinity. Whenever we say x approaches infinity, this says like as we move to the right of our graph what's happening, and then if we're approaching negative infinity in the x direction, that really is just saying as we approach the left side of the graph, where is it? Okay. In order to figure out end behavior, we need to know the degree of the function and the leading coefficient. So if we know the degree and the leading coefficient, first and foremost, our degree is equal to 4, and then our leading coefficient is -1. So if we have an even degree with a negative leading coefficient, remember even is that U shape, right? But that negative tells me it's going to be a frown that's turned upside down, right? So what I would do for every single one of these questions is just do a really rough sketch of what the graph should look like. And then you can talk about the end behavior. So as x approaches infinity, so as we're moving to the right, where is y going? So y is the same thing as that function notation for q of x, right? So if we're moving to the right, where is our y value going? Well, if we're looking on the right side of the graph, our arrow is pointing down, which would be towards negative infinity, right? So as we're moving to the right, our graph is going down. As x approaches negative infinity, on the left, what's happening to our y value, or q of x in this case? Well, it's, if you look on the left side of the graph, it's also going down, so towards negative infinity, right? And then we're going to do this again with example B with p of x. If our degree is 5, it's going to be a snake. And then our leading coefficient is 2, which means it's going to be a snake heading towards heaven, right? So this is going to be my shape. It doesn't flip. It's going to stay up as we go to the right. So if we talk about end behavior as I go to the right towards positive infinity, right? My y value, which is the same as p of x in function notation, right, is going to be going also towards positive infinity because it's going up, right? So as I look to the right side of the graph, if I'm looking on the right side, my arrow is pointing up. As x approaches negative infinity, as x approaches negative infinity, so as we move to the left, what's happening? Well, on the left side of the graph, my arrow is pointing down, so p of x, that function, is actually headed towards negative infinity, which is down, right? And then it says, for this next set of examples, it says determine a possible equation given the graph. So I see my ends are opposites, which means it has to have an odd degree because the ends are opposite directions, right? What are my zeros, right? That's another piece of information that I need to know. My zeros, I have a 0 at, let's just call it -2, maybe -0.75, 0, 0.75. We're going to call it -3/4, and then 3/4. And then we have another one at a +2. And then another piece of information to know is if your snake is going down, that means my leading coefficient has to be negative. Because my graph is going down, my snake is going to the basement instead of to heaven. So, keeping this in mind, if you're thinking about this type of question, right, we could go back to the beginning here and talk about my y is equal to, I have a negative leading coefficient. And then if you remember from chapter 6 earlier this year, if we had a 0 of -2, that would mean my factor would be x plus 2. If we had a -0.75, I could either write this as x plus 0.75 or 4x plus 3. Think about this. I would subtract 3 to the other side and divide by 4, which would give me 0.75. So either one of those would be a fine answer. And then here you do x minus 0, which is just x minus 0.75, or I'm going to say 4x minus 3 because that's how I like to write it, and then x minus 2. So here is my polynomial that I just came up with. It's got 5th degree. I see 1, 2, 3, 4, 5 x's. And my leading coefficient's negative, so it should be going down as I go to the right. We could do the same thing again with the second one. So my ends are going the same direction, so this must be even degree. Once again, that was because the ends are going the same direction. It must have a leading coefficient that is positive because I've got a smiley face, right? A weird looking smiley face, but it's happy. And then I need to know, what are my zeros? So if I'm looking on my graph, we'll just call that -5. And then I have -1, 0, and 1. So I can write my polynomial. My leading coefficient's positive, so I don't need to put a negative out front. I have x plus 5, x plus 1, x minus 0, which is just 0, and then x minus 1. And then you could distribute that to get it in standard form, but we're not going to do that right now. Okay, next thing that we could talk about is graphing a function. So if we were looking at this function, usually you want to look at your degree. The degree is 3, which is odd, so I know I'm looking at a snake function, right? My leading coefficient is positive, so my snake should be going up as I go to the right. So immediately I know on the ends, somehow I'm going to have arrows pointing up on the left and down, and somehow it's going to form a snake, right? One other piece of information that you can always steal is your y-intercept. It's always that last number in your equation. And then how many zeros can you have? in this case, due to the fundamental theorem of algebra, I know that I'm going to have up to 3 zeros. And then to find your zeros, you can either factor or make a t-chart. In this case, factoring won't work. So we're going to have to make a t-chart. I'm just saving you the time that factoring won't work. If we were to make a t-chart, though, you would have to pick x values and then just see how many times you cross over the x-axis. So I'm just going to give you these numbers. We could just plug in. Remember, we would plug into x cubed plus 4x squared plus x minus 6. And then we could plug this stuff in. I'm going to tell you where our zeros are and what these values are. Once again, you can just use a calculator. And then once you have all these coordinates, this should really help you to draw your graph, right? I have -3, 0, -2, 0, -1, -4, 0, -6. And then I have 1, 0, and then I have 2, 20, way up here, right? We already talked about how you have an arrow that goes down as you move to the left, and then your snake needs to go up as you go to the right. So my graph should look something like this. Am I going to make you graph a polynomial on your test or on an exam? Probably not, but the pieces of information you do need to know are how do I identify the shape, the direction, the y-intercept, what do I know about my zeros, and then how do I plug some stuff in. The last thing we need to talk about is a critical point. Once again, a critical point is where a graph changes from increasing to decreasing. Or vice versa. So if we were looking, I see a critical point here. And I see a critical point here. So I'm going up and then I'm going down. Here I'm going down and then I switch to the up direction, right? That is technically called a local maxima or minima. So it looks like a minimum, it's a local minimum. And then it might look like a local max. All right. Good luck on your homework.